6.1. All right, we're gonna save the best for the last because this is the, you kind of see the node order, like this is 6.1, which is something we're supposed to do first before we start, all this integration. But we're doing this last because there's a reason for that, because you need to know how to integrate to figure out what this means. Slope field is a very, very easy concept. It's basically called slope field for a reason. It's basically a field of slopes. You just draw slopes. That's like how easy that is. But obviously we have to do some FRQ. And then I think I told you at the beginning of the unit, there is a guaranteed FRQ over this on the AP test. So we have to practice FRQ using the correct notations. You're going to see a lot of that today. The notes is long, but it's really short. Anyway, first of all, slope field is basically a visualization of all the slopes. Without like doing any kind of integration or something, you just basically plug in. So like here it says sketch the order pairs, and then usually on the test I want you to do a few like order pair in the table like this. This thing dy dx, that is the slope, right? So like they will give you a equation. This is the differential equation, dy dx equal to something 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 something. That is the slope equation. All you need to do is just like plugging x values and y values into the equation, and that will be your slope, and you're gonna draw them. Obviously, when you draw them using some kind of short line segments, they don't have to be exact, because sometimes the slope can be very, very steep. Sometimes the slope can be very, very like flat. You just draw as best as you can. As long as you can show if the thing is increasing or decreasing or some kind of concavity, as long as I can see that, you're doing the right thing. Now, there's one thing you cannot draw. On the AP exam, you see those dots right there? That means you gotta draw a slope at every single dot they provide for you. If the slope is undefined, do not draw them. Because when the slope is undefined, in the real graph, the original graph, the graph might have like vertical asymptotes there. So we do not draw any kind of undefined slopes on the slope field. That's the only thing that's different, undefined slopes. Just leave it blank. Like, don't draw like vertical line there. If you draw a vertical line there, they don't know what you're doing. Okay, it's like if it's just leave it. Now on the actual test, I want you to do a few like plugins. Now let's do this. First one is really easy. They say the slope dy dx equal to x plus 1. First thing I usually like to do is figure out when is the slope equal to 0. So when is slope equal to 0, guys? When x is -1, right? So like that's number one thing I do. When x is -1, our slope is always 0. So you can write this if you want to. So that means every time you plug in -1 for x, doesn't matter what's the y value, your slope is going to be 0. So just do a few of those plugins. There is no like minimum requirement. At least you do like 2 or 3. 3 or 4 is enough. So same thing with -1 and 1. The slope is still 0 because there's no y value, right? It's just x value plus 1. So no matter what, over here, that's what you're going to do. Every time when x is -1, the slope is 0. So basically, you can fill like the whole column by just plugging in one order pair. Does that make sense? You don't need to plug in like a zillion order pairs. That's too much work. And then we want to see how is the curve doing as you're going towards the right or as you're going toward the left. Let's go to the right first. What happened when x is 0? So like for example, 0, 0. The slope is going to be 0 plus 1, which is 1, because again, we have no y value. So like the y value don't make any difference in our slope field. So every time when x is 0, the slope is always 1, right? So here the slope is 1. At 1, 0 and 2, 0 and 1, the slope is also 1, 0 plus 1. So like everywhere here, the slope is 1. So like we're just going to rise over run. This part you can just draw as, it doesn't have to be too accurate. Try as much as you can. And then what I want to say is, does your slope keep going steeper or less steep as you're going toward the right? What if I plug in 1 for x? What's the slope? 2, right? So basically, as you're going towards the right, the slope is getting steeper, right? Right now it's up 1/1, but now it is up 1/2. So you can draw a little bit more steeper slope. So same thing here. At 1 and 1 is still 2. Because again, there's no y value. We're just doing x plus 1, right? So all of them is 2. All of them is 2. Can you tell like the slope's getting steeper? Yeah. And same thing. 2. This is what 2, 0. The slope will be 2 plus 1, which is 3. So here we'll have a slope of 3, a little bit more steeper, a little bit more steeper, 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 steeper. And finally, at this point, you have a slope of 4. So it's hard. I know it's hard to draw really, really steep slopes. But again, I'm not looking for how steep it is. I'm just looking for like how you're changing the way it is. Okay, now what if I go this way? Let's do some kind of negative numbers. Like for example, you can pick any one you want, right? You can pick negative, what is it? 1, 2, negative 2, 0, or you can pick negative 2, 1. Doesn't matter. The y value still don't make any difference, but when I do negative 2 plus 1, you're gonna get a negative slope, right? So here I have a negative slope. So basically across the whole column, because again, we have no y value, makes no difference. And here, hopefully you already kind of notice this is gonna give you a negative 2 slope, which is a negative but steeper. That's all. Okay, now I need you to kind of notice what slope field do. Basically, the slope field is gonna tell you what the general solution look like. Okay, like what does the y graph look like? So you can tell like the y graph is probably decreasing and then flat and then increasing. So it looks like a quadratic. Can you tell? The original y graph, the derivative is x plus 1. The original y is probably a quadratic. You agree, right? You can also tell it's concave up. So as long as you can tell it's concave up, decrease and increase, you're doing the right thing. Now we're going to prove this is going to be a quadratic. How do we prove it? We can integrate it. So that's why we learn integration first before we do like slope field. To integrate it, you do what we've been doing. Separate the variable. I'm just going to integrate this one because I want you to connect what does slope field mean, okay, in your equation. So if I want to integrate it, I'm just going to move dx to the other side, right? And then integrate the left and integrate the right. Hopefully you're going to get a quadratic. So antiderivative for dy is y. The antiderivative for x plus 1, that's just reverse power rule. This is just like 1/2 x squared. You see this is quadratic plus x plus c. Remember, this is called a general solution. Basically, the slope field, when you draw a whole bunch of them, is a good representation of the general solution. It's like shape of the general solution. That's basically it. Right? They suppose look like your general solution. That's all. Now, sometimes they want you to integrate it. Sometimes they won't because it's going to be hard to integrate. So like we don't have to integrate all of them. We just need to know how to draw a slope field. So I want you to try the next one. I can kind of help you start it. We'll kind of see how you're going to draw this. First of all, when is the slope equal 0? This dy dx is x plus y. When is that going to have a 0 slope, you think? Sure. And then also, obviously, when x and y are the opposite signs, right? So like -1 plus 1, -2 plus 2, or 1 plus -1, 2 plus -2, right? As long as they have the same number but opposite signs, you're going to have a slope of 0. So you can tell. So this is the first thing I do is just figure out all the 0 slopes. -1 plus 1, -2 plus 2. So like they will have a 0 slope across diagonally. 1 minus 1, 2 minus 2. Okay, now the rest you gotta figure out if they are positive or negative by plugging some numbers. Again, you don't need to plug in every single point. Just choose a field to plug in, and hopefully you can do something else in your head. Okay. Again, on the test, I'm just looking for 3 or 4 order pair. That should be enough. So why don't you keep going, try to fill out that slope field. Help you out if you need. Keep going. Anyway, I want to finish drawing the slope field, plug in some numbers in your head. Give me a few order pairs in the table. I usually do like 1 order pair per quadrant. That should be enough. You'll figure out the rest. Okay. Keep drawing. Keep drawing. It's an easy concept. Very good job. I'm just going to borrow somebody's picture later. Whoever has the best drawings. Yeah, you can do some of this as you want to. Cool. Very cool. Just watch out some negatives. Sometimes I also look at like quadrant 1, all the slopes are positive, and then get steeper as you go. Very steep. Right? Oh, this looks nice. I have a picture. Almost there. Who has a good picture? Show them. There is use those dots. Those are the white values. We pick those dots. The white value doesn't do anything to the first picture, but the second one, the white value will do something, right? You probably won't be able to tell what this is when you look at the graph. That's okay, because this one is a complicated equation to integrate it, which we're not going to integrate. No, we're not. This is no, it's just weird. This is the one that you cannot separate them. So, which it's like a Cal 3 thing, but we're not going to integrate it. We just need to drop slope field. The finish. Can I borrow someone's picture and take a look? Oh, wow, yeah. This is enough. Oh, this is very cool. I like it. Thanks. Because I don't want to. Yeah. Like, is yours look somewhat like this? It's cool though. I like it. It's a very, very interesting curve. Nice. So you can tell it's completely up. Nice. This is nice. Oh, yours, I love it. Okay. Well, the next thing AP test might also ask you. Now, AP test, they might not ask you to fill out a whole bunch. Usually, they give you like 9 points to fill out. Okay. Another thing you need to know for our thing is you need to know how to draw the solution curve. So when they say, oh, hey, I have a slope field, dy dx equal to x times y. And then here is a slope field. This slope field has a solution curve. Solution curve means like shape. You want to draw some kind of shape through your slope field. The solution curve must go through this point 0, 1. That's shown below. When you draw the solution curve, again, you just basically go with the flow, right? It looks like a quadratic or maybe something else. Now you have the requirements very, very simple. You have to go through this, which is the initial value. You have to go through initial value. And the number one thing you need to remember is do not draw arrow. The reason why we don't draw arrow is because slope field is only a portion of the graph. You don't know whether or not the slope field will go like some other way where they start decreasing and concave down or whatever after beyond this point. So like if you draw arrow, pretending you keep going up, but we don't know because this is only a portion of the graph. Okay, so do not ever draw arrow here. On this same picture, they want you to draw the solution curve through the other two solution, like order pair. 0, 2 is right here. So basically, you just need to follow the flow. It's concave up, decreasing and concave up, and then increase, decreasing, go through here, increasing and concave up. So that's basically it. As long as you show that is enough without drawing arrows. Okay, so that's the first one, part A. Part 2 is going through 0, -1. The one down here is increase and then goes through the point and then decrease, and it's concave down. So you should drawing a upside down U instead. As long as you follow the flow, you should be good without drawing arrows. Done. Super, super, super easy. And then you gotta go all the way, extend it all the way to the end. Okay, don't draw something just like that, like you can't stop here, right? Just go all the way to the edge, but do not draw arrows. From edge to edge, follow the flow. All right, easy stuff. Okay, next I'm gonna make you guys talk to the person next to you. You're supposed to match the slope field with the equation. Now keep in mind, this is the general solution. This is not dy dx. So they already told you the general solution. So basically, you're just looking at a shape, which one look like y go 1, which one look like y go x, like as the general shape, which one look like quadratic, which one look like cubic. So mix and match. Let's go. I want you to figure it out. It's really, really, really easy. Look at the shape. Try to draw the shape inside. Help each other out. Too easy, right?
Yeah.
What's the y look like? What's the general solution look like? I'm gonna try another. Minor one, 0 slope, straight, hopefully. Do you know what natural log of x look like? If you forgot, I can draw it for you. Hopefully, process elimination can help.
Because is it sine 0 and 0?
Sine goes to 0. If you forgot what natural log and exponential look like, they do look like this.
No, that's not what you want.
You need to know what they look like, right?
See what she says.
Yeah, because if you plug in 0,
You don't have to plug in because this is not dydx. This is just like a general shape. Oh, yeah, you could plug in to find the initial value. That's true. Like, because they have to go through the initial value.
0, 0. So yeah.
Yeah. So you try to figure out which one is sine, which one is cosine. Yeah, cosine starts at 1. Sine starts at
so B would be cosine.
yeah.
That's what I'm saying.
Yes, sine and cosine, right? Just look at sine starts at 0. That's what sine curve looks like. And then what's the slope at that point? It goes like this. Cosine starts at 1, right, guys?
Well, A and G have to be
I'll give you a little more time. I'm going to check answers pretty soon. Cubic looks like an
I
S.
think it loves me.
There's asymptotes there, you can tell, right?
No, I think F is LN maybe? Or wait,
I said I was supposed to. I don't know. It might be. It kind of.
Okay, you guys almost ready? Did you find them all? Oh, you're on the back side already. Okay. Don't go too fast. It's cool. It's cool. You can look at the next one. You want, everyone on the same page. Keep going. I'm going to check answer please on number 4.
Zero. Yeah, because
not really. It's easy. Look, this is that's what I got. Yeah. Okay, are we good? Check answers. Anyone else stuck? I can help you unstuck. G is easy.
Are you 100% sure?
You think about everything else. Qubit is this one. LN. You know how LN on the, if it's positive, it's on the right. If it's negative, so it's gonna be.
So
Oh, that's too fast. We're gonna check answers. He's ahead of us. All right. Okay. Also, again, make sure you know what does LN X look like. Okay. What does E to the X look like? Because one of them is LN, but absolute value. Okay. Check answer for D. For this first, I mean, I kind of drew them. D, H, C, F is the 7, 8, 9, 10. Right? Do you get them right? The last one is you should need to know what LN and X look like. So process elimination can help you. And then the sine and cosine, right? They are different by looking at slope. At 0, the slope is positive for sine, but at 0, the slope is 0 for cosine. Yeah, are we okay? Any questions? No. Okay. All right. So this one is matching. Use the general solution. The easier one is matching by using the derivative, right? The slope. So like for this kind of question, you can just plug in numbers because they will give you the slope at that point. And then now the next, keep going. Which one's which? I'll see if you did it right. Oh man, you did everything great. Huh, good job, man. You did so that close was easy. Okay, plug in numbers, guys. Also, when is the slope equal 0? Remember, that's also important, right? How do I know when the slope is 0? Sometimes you can also find out by looking at the undefined slope, like number 18. When the y value is 0, it's always undefined. So that means you should not see anything at that point. But there's more than, anyway. Again, help each other out, plug in some points in your head. On Miss Lu's test, you do have to show me a little plug-in. Okay? That's just one you can do. It's too easy. Okay. Oh, mine, too easy. Okay. Again, on my test, just plug in a few points. Okay. I feel like this one's easier than the other one, right? Which one's easier? Most of you already have the answers. Well, what's 15? Did anyone find it? It's B, yeah, because when x is -2, the slope is 0. So like all of this, very, very easy to tell. Done. If you want to write anything on the test, this is what I will provide. Okay, like what table? What about 16? D this. So this one has no x value. So like every time when y is what is that, right? When y is 1, the slope is 1. When y is 2, the slope is 2. When the y is negative, the slope is negative. Whatever. That's really easy. 17, what's the answer? Anyone find it? see this. How do we know that one? Again, x minus y has to be 0. So just pick a point, right? 1 minus 1, that's 0. Wait. Sorry. You're right. See, right there. 1 minus 1 is 0. 0 minus 0, you know, those are the ones I'm looking for. And finally, a should be this guy, because you can, again, plug in a point. At 1, 1, the slope is negative. So just plugging a few points will help you. Usually I do like 2 points, just making sure, or each quadrant. All right, done. Any questions? Now we're gonna work on some real FAQs, free response questions. Like I said, you're gonna see them on Ms. Lu's test next Monday, obviously. So I'm gonna show you the proper notation going through this, and then what I'm looking for. Okay, so like consider this differential equation. They told you the slope dy dx is x squared times by y minus 1. Now, first thing first, I want you to draw your slope field. Again, you can figure out when the slope equals 0. When is the slope equal 0, guys? When the x is 0, the dy dx is always 0. Where else? There's another point. What about the y? Yeah. Okay, so sometimes you gotta look at 2 different things. Okay, x equals 0. So every time when x equals 0, like all of this, I can already fill out 1, 2, 3, 4 of them without doing any table. It's automatically 0. And every time when the y equals 1, it's automatically 0. So like all of these things, I can just fill it out without doing anything, right? The table. And now the rest, you can do tables, okay? So like continue doing this. On the AP test, make sure you fill out every single point, unless the points are undefined, we're gonna skip them. So the only leftover points I have is 1, 0. At that place, the x is positive, the y is negative, so it's 1 times by -1, which is a -1 slope. Same thing at -1, 0, -1 slope, because x is always positive. What else? Here's 1, 2. At 1, 2 is 1 times by 1, which is a positive slope. At 1, 3, okay, it's 1 times by 2. So it is a steeper positive slope, and should be the same thing on the other side, because your x value always positive. Again, once you figure out the pattern, you don't need to show me too much work for plugging, I hope. Yeah. Any questions? Easy stuff. Now, what we're going to do is we're going to answer some questions related to this free response. Describe, part B, all the points in this XY plane which the slopes are positive. Where are the slopes positive? Where? Like all the points. We cannot just provide one at a time. Oh, yes. Yes. Every time when the y is greater than 1, what else? There's another condition. What about x? X cannot be 0, right? Because if x is 0, what's going to happen? You're going to have a 0 slope, right? So every time when this 2 condition meets, right, they're asking you all the points. Like if I continue on, everywhere when the y greater than 1 and x is not 0, like right there, it is positive slopes. So let's write a complete sentence for FAQ. Slopes are positive. Done. Okay, now the next thing, I don't have space, so I'm going to use a different sheet of paper to complete my notes. Find the particular solution for y equal to f of x to the given differential equation with the initial condition of y of 0 equals 3. So this is something you've been doing for the last week or so by doing integration, right? This is why we learn integration first, and then using the initial condition. So like that's what we learned last week. So first thing first, we got to separate them. What's the legal way to separate this? Yeah, divide y minus 1 times by dx, right? Correct. Why don't you guys practice integration? This should be something you done already. Hopefully everybody's experts. Don't forget the integral symbol. start integrating, you might need to do, how do you integrate dy over y minus 1? You already know what that is. Okay, start integrating. Don't forget the initial condition. Okay, so that means we're going to plug in the initial condition as soon as possible. I know some of it can do this in your head, but try not to still do like the u sub thingy. As long as you can, I see this, you can do this in your head, right? This is like du over u. So what's the integral for dy over y minus 1, guys? Can you do this in your head? Yeah, which is the ln that, yes. Natural log absolute value y minus 1 absolute value. On the right hand side is 1/3 x to the third plus c. Right. The next thing you're going to do is plug in numbers. What's my initial value? F of 0 is 3, so that's ln 3 minus 1 is 2. Again, you don't have to have absolute value here. So the c value is natural log of 2. Did you get the correct c value? You're going to earn a point for that. And now going back to the initial function, we have 1/3 x to the third plus natural log of 2. What do we go from here? E, very good. E. Now save stops, because this is FRQ. I don't recommend you to split them up unless you know exactly what's going on. Okay, I don't want you to split them apart and then do them wrong. So I just leave it. I recommend that. It'd be just e to the 1/3 x to the cube on the plus ln 2. Now, if you have to split this apart, it will look like 2 times e to the 1/3 x cube. But again, I don't recommend you to split apart. Okay, so let me just do plus minus. This is called a safe stop, guys. Leave it as this. We're gonna add 1. It's called safe stops. For those of you who really want to split up, there will be a 2 in front of this. Still plus minus. Don't forget plus minus. Oh wait, is it positive or negative? We don't know. Is it which one? Plug in 0. It's e to the ln 2 plus 1. E to the ln 2 is 2, right? 2 plus 1 will be 3. So the answer should be positive. Yeah. So final answer, 1 positive. You can put the 1 in the front or at the back, doesn't matter. Because the initial value is f of 0 equals 3. We have to satisfy the initial values. So final answer should only have 1 answer, not 2 answers. Any questions? Hopefully you did something like that on the circuit training. I mean, it's the same thing. Just with the initial value, that's all. All right, we're gonna do a little bit new things on the backside. My gosh, equation of tangent line. I don't know how many times I need to ask you this question on the test. It's every test. People still mess up every test, especially the last test. I don't remember how many questions people actually get that question right. Maybe like 2 people every class. So we're gonna do it again. That one, I mean, I agree. That question was hard. But this is an easier equation of tangent line. Hopefully, we're not gonna miss this one next test. So let's do this again. Let f be the function f of 1 equals 3. That's our point. Such that all the points on xy plane in the graph, so that the slope, this is slope, equal to dy dx. The slope is given by y divided by x squared. So I'm going to review the notation, guys. Please don't write n for slope. I still have people writing that. I don't know why. The slope of the graph at f when x equals 1. Okay, so now again, we're looking at the initial condition. When x equals 1, the y is 3, right? So that's our order pair. So to find slope, what's my notation? Dy dx at this point, right? So please practice writing your notation. Dy dx with a bar at the point provided for you, which is the order pair, 1, 3. That will be the correct notations. Equal to plugging, all you need to do is just plugging, right? So plugging 1 for x, plugging 3 for the y. What's the slope? 3 it is. Done. All mixed with grading is your notation and your answer. You can also write at 1, 3 dy dx is 3. That's fine. Or you can do this bar thing. Okay, now, oh my gosh, equation of tangent line, here it goes again. Write the equation of tangent line to the graph of at this point and use it to approximate f of 1.2. So again, we need to have two things for equation of tangent line. We need a point, which we have. Let's start over with the equation of tangent line, like pretend you never learned this before. We need a slope, which we already learned. We got is 3. All you do is just y minus y1 equal to slope x times x1, right? Don't leave anything blank. You lose like 10 points for that question, by the way. So it is y subtract 3 equal to slope x minus 1. What we're going to do next, plug in 1.2 to find the y value, right? Now you can do safe stop again. So 3 times 1.2 minus 1. You don't need to show me this work. Just do it in your head. 1.2 minus 1 is 0.2. So I am okay if you don't want to compute 0.2 times by 3. Just write 3 times 0.2. And then we're going to add 3. Again, this is called safe stop. I have people keep computing wrong. So if you don't believe your computation skills, stop here. But you're not done yet. What's missing is the notation. We want f of 1.2, right? So f of 1.2, what should I write next? It's approximate. There you go. And then you can write this thing if you want to. 3 times 0.2 plus 3 is whatever. But I'm going to compute this easy. This is 3 plus 0.6. Okay, so again, you don't have to compute this, you and me. Like, be safe on the test. Don't forget the approximation sign. And that's all like you need to do. This is like hopefully like an easy slope of tangent line. Okay, now we have one more thing we need to do. This is something we learned a long time ago. You probably already forgot. They told you the second derivative, d squared y over dx squared is equal to boom. Determine if the approximation we found is greater than the actual value or less than the actual value. Justify your answer. Do anybody remember how to do this? Like, remember? Let's review. Like, what does second derivative tell you in the graph? Huh? Concavity. Okay, so if the graph is concave up, and then here's my equation of tangent line. Here's a number I want to predict. What can you tell me about my prediction? It's underestimation. If the graph is concave up, here's my equation of tangent line. Here's my, I don't care where is the prediction. This will be greater than the, right? So like it's about this. So all you do is to figure out if this is concave up or concave down by doing what? How do we know? Plug in what point? 1, 3, not 3 point, not at 1.2, right? So what's the notation? The d squared y over dx squared. At the bar, this thing 1, 3. Again, safe stop. You don't actually have to compute it. Can you show me that? Oh, I plug in 3 to y. I plug in 1 to x. That's divided by 1. That's supposed to be a negative number. That's all I need to know. I don't need to compute this. This can be very, very complicated number, right? Like if the second derivative is super complicated. So what can you tell me about this? Yeah, there you go. So let's write a conclusion. You guys need to practice write a conclusion. What can you tell me? Like what's happening at this point, right? The location 1, 3. Our second derivative, d squared y over dx squared. What about that? It's less than 0. Or you can say it's negative, whatever. Since that's happening, what can you tell me? I know the f of x is concave down. You have to tell me that, right? How do I know? You have to tell me something about concavity. Since it is concave down, our approximation is greater than the actual value, or you can say the approximation is a overestimation, whatever. The approximation is greater than the actual value. A complete sentence. It's gonna be fine. All right, any questions? All right, now, so save our time. Number 8 is also very, very good FRQ. I'm going to do majority of it, but maybe skip a little bit part about part C because I feel like you guys are experts of solving things like this. It's this kind of things over again, you know, they never ever change. That's a nice thing about our FRQs in the AP exam. They don't change. It's just they change numbers, maybe changing the equations. Maybe they'll give you some hard FRQs that make you go crazy, but still, there are some questions that they never change throughout the years. Differential equation is one of them. Let me read this. So we can do part A and part B, and then probably just do the beginning of part C will be done, right? At the beginning of 2010, the landfill contained 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at this place. The planar estimate W will satisfy the differential equation. Here is our differential equation with a dW dt. Make sure you use the right variable, by the way. For the next 20 years, W is measured in tons, T is measured in years from the starting of 2010. Okay, see if you can do the equation of tangent line again. Part A, use the tangent line to graph W to the graph W at t equals 0 to approximate the amount of solid that contains at the end of the 3 months, which is t equals 1/4. All right, so first of all, we need an equation of tangent line. Do you know what point we're supposed to use? 0 and 1,400 is right there, right? That's our initial value. How do we know that's because it says starting at 10, 0, t is 0. This is our t. This is our w. Yeah, that's not w of t. That's w. This is not dw dt. This is w. This is the time. So that's our initial value. Do you know the slope? We gotta find it, right? How do we find slope? Plug in. Okay. So the first thing first, write your notation down. dw dt. At what point? This point 0 and 1,400. Plug into your dw dt equation, right? Now in your dw dt equation, there is no t. So all you need to do is plug in 1,400 for w. And then you can do, again, save stop. 1,400 minus 300. So like that will be our safe stop if you want to stop here. But I'm going to write a little bit better because we need that for equation of tangent line. So don't like do too safe stop, okay? I'm going to write 1,100 over 25. Whatever that is, I don't care. But that's the slope, okay? Now my equation of tangent line. You cannot use y. What's the variable we're supposed to use? The w minus 1,400 is equal to our slope, 1,100 over 25. And then what's the input? T, that's right, t minus 0. And then stop here. Don't distribute. I have people that try to distribute them and then they are wrong. So just stop here. That's my equation of tangent line. And now what we're going to do next is we're going to plug in 1/4, right? So again, here's what I'm talking about for safe stop on the test. When you're plugging 1/4 for the t, it just 1/4 times all of this, right? So what's my notation? It's w of 1/4. Approximate to be safe stop. 1,100 over 25 times t is 1/4 minus 0 is 1/4, and then adding 1,400. Safe stop. Nobody wants to compute this. Trust me. You have no time on the AP test to compute this anyway. Stop here. If they want units, we're going to provide units. Do you know what's the units for this? Yes. Okay, Tom, see this? Good job. I still have a lot of you do not like units for some reason. You gotta practice units, guys. Okay, now we're gonna do part B because this one's a little bit different. It's kind of going back to the things we done a long time ago. We need to find the second derivative in terms of W. Using that, I mean, the approximation part is easy, right? Once we find the, you know how this question, they already told me the second derivative. And then how do I know it's over or underestimate? I just need to plug in, right? So the difference between this versus this is like they don't give you the second derivative, which means you gotta find the second derivative first And then you can tell me if it's over or under estimation. So I need to remind you how to find the second derivative in terms of W. So first of all, d squared W over dt squared, what does that mean? It means I'm taking the derivative with respect to t of your original dw dt. What is my original dw dt? It is 1 over 25. I'm going to go ahead and distribute this because it's easier to do derivative again. 300 divided by 25, I don't care what that is. So what Ms. Lu did is I went ahead and distribute this. Okay, for derivative, you don't want to distribute this for antiderivative. You know what I mean? So that's the part like people will get confused. Why do I do derivative? I distribute. It's because I want to do like constant. This is like easy derivative, right? Nobody wants to do product rule with this. Do you want to do product rule with this? Nobody. So like that's why I distribute it. Okay, but when you do antiderivative, you don't want to distribute it because it's so much harder to do antiderivative. So can you, what is the derivative here, guys? It's 1 over 25 with a d what? We are taking the derivative with respect to t. So it's 1 over 25 dw dt, right? It's the implicit differentiation. It's coming back. We are about to get to the AP review, so you need to remember all these kind of things. This kind of thing will be, it's kind of together. So the here, second derivative is gonna be 1 over 25 times dw dt, because we are taking the derivative with the w with respect to t. That's what that is. Now that's still not over. Because you did not answer the question. They want to say find d squared w d square dt square in terms of w, not in terms of dw dt. So now what should I do, you think? How do I make this in terms of w? What's dw dt? It's just this, right? So this is in terms of w. So what they mean is they want you to replace this, whether it's distributed or not, don't matter, into this. And that'll be my final answer. Save stop. So again, without distribute, with distribute don't matter. I'm gonna stop here. So that's what I mean by taking the second derivative with respect to, in terms of W, that's what that means, okay? Now, can you do the concavity in your head? I mean, we don't have to finish this. What point are we talking about? At 0, okay? So now at 0, 1400, is this positive or negative, guys? D squared W dt squared, positive? That means your W of, you can say the W graph is concave up, which means this is a what? Underestimate. Okay, you can finish the rest. Okay, so I'm gonna kind of like W of t is concave up, which means the approximation. Wait, I don't even do the approximation, but you can do that yourself. Whatever W, we already did the expression right here. The approximation we did in part A, the W of 1/4. That's the approximation is under. Wait, concave up is under. Yeah. The rest is easy, right? That's pretty much it. You just need to show me this. You don't even need to tell me how you compute it. You can do all of that in your hand. It's not a problem. I mean, assuming you know you plug in 1400 minus 300, whatever that is, times by 1/25, times by 1/25, it cannot be negative. So that's enough to show me, right? Done. All right. The last question, I'm just going to stop at the point where you know how to integrate, and then we're done. Find a particular solution WT of the differential equation. How do we separate this legally? How do we separate this? Divide W minus 300 only. Do not divide it by 1/25, right? So let me just stop here because I trust all of you know how to do integration because this is like such an easy one. Again, you're going to see this LN thing. Again, you're going to see this, it's the same exact question we just did right here. Not any difference. but plugging 0 and 1400 instead. Okay, so I'm just going to stop here. You know this kind of question you are expecting to see on your test, and so very good. All right, done for the day. Okay.